Hello and welcome. Now you've just watched a video where Mr. Nelson has explained how you gather data in class for distance versus time or velocity versus time. And he brought up the scenario of you gathering information in a laboratory. Now it's very common that we ask you to graph that information using digital means, and so I would like to demonstrate how to do this. So we're going to be using a program called Sheets. And so if you go to your Google Drive and click New, one of the selections is Google Sheets. Now this is a spreadsheet program, which is basically a good way of keeping track of numbers. And I really suggest that you title it in the beginning something that has some meaning. So Mr. Nelson's example. And that means that once it's in your Google Drive, you'll be able to find it again. Now, this is what a spreadsheet program looks like, and there's thousands of these boxes. The way in which we distinguish a box is we put the cursor in a box and we left-click once. And you will see that this A is highlighted and this 1 is highlighted. Now, in Mr. Nelson's example, he spoke about time, and every time that you want to put a label on a column, you need to include a unit. And he spoke in seconds. And then he also spoke about displacement in meters. Now something interesting has happened. You'll see that this word has gotten a little bit larger than the column, and so I'm going to click B here and move until my cursor, I get this double arrow, hold down the left mouse key, and I can make the column wider to accommodate what I have. So the numbers that he offered were times 0, 1, 2, 3, and 4. Now what's cool is you can use your typewriter to type your keyboard in order to put these numbers in, or you can simply copy and paste. And then the displacements he had were 0, 1, 4, 9, and then 16. Okay, so given this information, we've created a little table here very similar to what Mr. Nelson had. Let's graph it, or let's allow Google to graph it for us. So I want to highlight this data, and this is how I'm going to do it. I'm going to take my cursor and put it in cell A2, that's the first number I want. I'm going to hold down my left mouse key, and you'll see that this blue box forms around this cell. And if I take another finger while continuing to hold down the left mouse key, I can drag down, and you'll see that 0, 1, 2, 3, and 4 are all highlighted in blue. But I also want to move over to the right and highlight these numbers in blue as well. When I release, I'm going to get this blue box around the data that I'm going to graph. At this point, I'm going to do something called Insert Chart. There's two ways to do it. I can go to this Insert menu, Chart, or if you look, there is an Insert Chart hotkey, which is right here. Insert Chart. Either way will get you to where we're going. And by default, Google is going to present you with this column chart. Now these tend not to be very useful in science class. So why don't we change our chart type over here from column to what's called a scatter graph. This means that it plots the points very much the same way that Mr. Nelson did. And what's cool is it has put a title in the top here, displacement versus time, which is required on all scientific graphs. And then also it's put the title of the y-axis here and the title of the x-axis here. Now to be honest, this ain't a bad graph to begin with, but we can make it better by using this customize feature over here. Okay, so first off, displacement versus time. Now, Mr. Nelson used two different phrases. He used displacement, but what if we wanted to use the word distance? What if we wanted to talk about distance? Now, I can go back to this cell and change it to distance, and you'll see that it doesn't change the title. That's all right, we can fix it. I'm going to double-click inside the graph, and these three dots gives you a menu. I'm going to edit chart. I'm going to go to customize, and if I edit the chart axes and titles, you'll see that the chart title right now says displacement in meters versus time. Well, I can change that. I can make it distance versus time. If I want to change the axes, the labels here and here, I can do this in the same place. Not chart title. I use vertical title, and it tells me that currently it says it's displacement. Well, I'm going to change that to distance. I could change the horizontal one, but to be honest, time is very good. Next, you'll see that it has a legend right here, which doesn't help me very much. So I'm going to select legend, and it says position. You can put it on the right or the top or the bottom, but to be honest, I don't want it, so I'm going to put none. Okay. And then finally, Mr. Nelson drew a line between all of these points. That is under the series option. You can add something called a trend line, which is found right here. The thing is, the kind of trend line that you add dictates how good it is. Now currently you will see that this is a linear trend line, and to be honest, it doesn't fit the shape very well. So I'm going to poke through here and find polynomial, and you'll see that my trend line goes through all of my points very, very nicely. And I can do things like change the color of the line if I want, or how thick it is so that you can really see it, or what its opacity is. The last thing that I'd like to change is you can put a label so that the equation of this line shows up, which would be very cool in the velocity versus time graph. The last thing I'd like to do is you'll notice that my graph right here doesn't necessarily start at 0. So I'm going to go to the vertical axis, and I am going to treat label as text, and that means that it starts at 0 and progresses up. Now if you pay a lot of attention, this is the exact graph that Mr. Nelson generated. What's cool about this is, now that you've developed this, you can go to these 3 dots, copy this chart, and then paste it back into your lab report and have a digital version of the graph in which the computer has optimized everything for you. So at this point, we've developed a distance versus time graph, which is useful, but then Mr. Nelson also demonstrated an average velocity versus time graph. Let me show you how to do that. Down here at the bottom, there's a plus sign, and it says add a sheet. So I can get a whole nother sheet. Now you might go, I just lost all my information. If you look here, sheet 1, that's your distance and time. Sheet 2, that's a whole new blank graph. What's cool is you can change these names by right-clicking, and on Chromebooks that means tapping the pad with both your index and your second finger, and renaming. So let's call this velocity versus time. Okay, so one more time to review. One column I had time, and I need to include the unit seconds. And for my next column in cell B1, I'm going to put velocity, average. And I'm going to include my units, meters per second. Now if you notice, once again, this text is wider than the column, so I'm going to highlight the column, move until my cursor has a double arrow, and make the column wider. The times that Mr. Nelson had were 0, 1, 2, 3, and 4. But then he calculated the velocity at various different points. The velocity at time 0, there is no velocity, so let's start with 1, and Mr. Nelson calculated that that velocity was 1 meter per second. And then at velocity at 2, it was 3 meters per second. 5 meters per second, And then he calculated that the velocity average at the last segment was 7. But I'm going to intentionally put an error in here so that I can fix it later. So I'm going to put 8. At this point, it's time to graph. So I'm going to highlight all of this information. We're going to add something though. We're going to add this label of this column and this label and see what Google Spreadsheet does for us. So I'm going to hold down my left mouse key and I'm going to put a blue box around all the information that I want it graphed. When I let go, I get this blue box around it. I'm going to go to the Insert menu and Insert Chart. Once again, Google Sheets gives me a column chart. I want a scatter chart. So I'm going to scroll down here until I find scatter. Okay. I can move this over just a little bit. And at this point, I've got velocity average on this axis and time on this axis. I really don't need this legend, so I'm going to go to the Customize feature, the legend, and I'm going to remove the legend. Alright, at this point you will see that these 3 points line up pretty well, but oh, I made an error right here. I said the velocity average was 8. What's cool is I can go fix it here and watch what happens to this point when I put 7 in here. 7. Did it fix it on my graph? Yeah, I don't have to graph all over again. And now at this point you will see that all of these points form a nice straight line. Let's add a trend line. So I'm going to click inside the graph itself, 3 dots, Edit Chart. I'm going to go to Customize again, but this time I'm going to look for Series. I want to add a trend line, which is a feature right here. And the trend line I want to add is linear. That's good because it's a straight line. So let's see, I'm going to change this color to be green this time. I'm going to make the opacity 100% and I'm going to make it a pretty thick line. Now what's interesting is the slope of this line represents the acceleration of the car. What's cool is Google Spreadsheets will give you the slope of that line. If you notice right here it says label, and right now there's no label, but we're going to use the equation, and when you do, you get the y equals mx plus b equation right there. That is the slope of this line. It's telling you that 2, or the m, is the slope of this line, and so therefore the acceleration is 2 meters per second squared. Once again, if I want to drop this into my laboratory, I can hit the 3 dots, copy chart, and then go back to my laboratory and paste it into a new Google document. Good luck!